Now the next one, just observe. So whatever we covered, hash map we discussed what are various methods present in map, and what is the hash map, what are various properties satisfied by hash map, like, and what is the difference between hash map and hash table, the most valuable question for the entire room. And then the next small variations of hash map we have to discuss. Small variation, linked hash map. A special case of hash map is the linked hash map. Identity hash map, a special case of hash map is identity hash map. Weak hash map, like. So there are three small variations of hash map is there. These are exactly same as hash map with a small differences. What those differences we have to discuss. Keep submitting. Linked hash map, linked hash map, linked hash map, linked hash map. Do you know in the last session somewhere we covered hash set concept? Have you remembered hash set? And even linked hash set also we covered. I hope you people may aware hash set and linked hash set. Linked hash set is the child class of hash set. And what is the difference between hash set and linked hash set? In hash set, insertion order not preserved because it is based on hash code of hash code. But here linked hash set insertion order is preserved, and here underlying data structure is hash table. Here underlying data structure is linked list plus hash table. Like same difference you can expect about hash map and linked hash map. Are you getting right? Same linked hash map is the child class of hash map. First point. Second, linked hash map is exactly same as hash map with these differences only. Okay, this is what those differences. Let me highlight right. Okay, here see, sir, here I am taking hash map and linked hash map. What differences here? Hash map and linked hash map, right? So in the case of hash map, the underlying data structure is hash table, we covered already. But in linked hash map, underlying data structure is linked list plus a hash table. Linked list plus hash table. Okay, like this is. Now the second terminology. Okay, make sure you people should be aware. So here insertion order is not preserved. Insertion order is not preserved, and it is based on hash code of keys, and it is based on hash code of keys. But here insertion order is preserved. Insertion order preserved, that's all. This is the major difference. Is nothing but the main difference between hash map and linked hash map. In hash map, insertion order is not preserved and it is based on hash code of keys. But in linked hash map, insertion order is preserved. Okay, this is now the third one introduced in 1.2 version, introduced in 1.4 version. Except that there are no other differences between a hash map and a linked hash map. Are you getting? I will execute the program. So anyway, up to this is it clear, right? First add the points. Add linked hash map. It is the child class of hash map. It is the child class of hash map. Child class of hash map. Child class of hash map. Next up. It is exactly same as hash map. It is exactly same as hash map. It is exactly same as hash map. Hash map within bracket, including methods and constructors. It is exactly same as hash map within bracket, including methods and constructors, except the following differences. Except the following differences. Except the following differences. The following differences. Except the following differences. Okay, take this one. Hash map, linked hash map. Hash map, linked hash map. Hash map, linked hash map. Okay, first point. First one hash map, second one linked hash map. Take the table. I will dictate the points anyway. First column hash map, second column linked hash map. Linked hash map. Okay, at the first point, the underlying data structure is what is the underlying data structure? Underlying data structure is hash table. Underlying data structure is hash table. Next, other side, underlying data structure is a combination of underlying data structure is a combination of underlying data structure is a combination of linked list plus hash table. Linked list and hash table. Underlying data structure is a combination of linked list and hash table within bracket hybrid data structure. Hybrid means mixed combination. Hybrid data structure. Next, second, insertion order is not preserved. Not preserved, and it is based on insertion order is not preserved and it is based on hash code, of keys. Insertion order is not preserved and it is based on hash code of keys. Next, other side, insertion order is preserved. Insertion order is preserved. Next, third one, introduced in. Now, can you tell in which version? Introduced in 1.2 version. Next, other side, introduced in 1.4 version. That's all. Are you getting? Now just observe the point well. Here see this example. Observe this one. Here I am taking in this example Hashmap example, right? In this example, what is the output we got? SOP of M is nothing but like all the remaining SOPs. Let me comment on all the remaining SOPs I am commenting. Okay, just only SOP of M, that's all. Okay, so all SOPs let me comment, because so you should not get any confusion. Here see this point. Sir, here it is the normal Hashmap SOP of M. In which order we are adding key and values? First Chiranjeevi, next Balakrishna, Venkatesh, Nagarjuna, right? Let me compile this code. Sir, let me compile. What is the output we got? First which one who came? Nagarjuna, Venkatesh, Balaya, Chiranjeevi. Can I use the term, is it insertion order? No, because insertion order is Chiranjeevi, Balaya, Venkatesh, Nagarjuna, but here some other order. Now what I have to do, sir, insertion order must be preserved. Then instead of Hashmap, let me take what? Linked Hashmap. M is equal to new linked Hashmap. Linked Hashmap M is equal to new linked Hashmap. Now observe what is the output by default we are getting. Have you observed? Chiranjeevi is equal to Chiranjeevi, Balaya, Venkatesh, Nagarjuna. Can I use the term, is it insertion order or not? Yes. Chiranjeevi, Balaya, Venkatesh, Nagarjuna, insertion order, right? That is the small minor difference between Hashmap and linked Hashmap. Are you getting right? So in Hashmap, insertion order preserved or not preserved? Not preserved, but in linked Hashmap, insertion order by default preserved. Clear for all of you at this point also. In the above example, in the above program, don't ask where is the above program. Already there in your notes, Hashmap program. In the above Hashmap program, if we replace Hashmap with the linked Hashmap, in the above program, if we replace Hashmap with the linked Hashmap, then output is better to take this output from the screen. Output is curly brace open, Chiranjeevi is equal 700, comma, Balaya is equal to 800, comma Venkatesh is equal to 200, comma Nagarjuna is equal to 500. Chiranjeevi, Balaya, Venkatesh, comma Nagarjuna is equal to 500, like. Can I complete it, right? Okay. That is insertion order. That is insertion order. That is insertion order is preserved. Insertion order is preserved. Preserved. That's all. Insertion order is preserved. But here one small point I have to highlight for you people. Have you remembered in the last class I covered this point also? Linked hash set. Very common application area is cache based applications. Have you remembered cache based applications where duplicates are not allowed, insertion order must be preserved. The same thing is going to be happen even in this case also. So linked hash set and linked hash map commonly used for developing cache based applications. Are you getting it? Take a note. Linked hash set and a linked hash map, linked hash set and a linked hash map, linked hash set and a linked hash map are linked hash set and a linked hash map are commonly used for developing cache based applications. Commonly used for developing cache based applications. For developing cache based applications. Cache based applications. That's all. Are you able to understand the conclusion, right? So this is what you people should aware. What is the linked hash map? So normal hash map, linked hash map, exactly same with a small minor difference. What is the difference, Anna? In a hash map, insertion order is not preserved, but in linked hash map, insertion order preserved. Clear for all of you, right? Okay, this is. Now next thing what we have to discuss, identity hash map. Okay, this is. But before discussing identity hash map, there is one concept you should have clarity. Then you can able to understand easily, right? Let me highlight first and then you can take anyway this. Sir, do you know what is the difference between double equal operator and a dot equals method? Even we covered already in the last classes. Not required to keep any explanation about this one. In the operators concept especially I told, even in the lang package also while covering equals method, there is a big table I provided. But let me observe. Let me repeat once again. So double equal operator meant for reference comparison or address comparison. Are getting reference comparison or address comparison? But dot equals method in general meant for what? Content comparison, right? Are you getting? Sir, can you explain with an example? Just you people may ask. Here see, sir, I am taking integer I1 is equal to new integer of 10. Assume integer I1 is equal to new integer of 10. So I1 pointing to 10. Integer I2 is equal to new integer of 10. Okay. So I2 is a pointing to another object, but content is the same 10 only. Okay. System.out.println I1 double equal to I2. System.out.println I1 dot equals I2, like I1 double equal to I2, I1 dot equals of I2. Sir, I1 and I2 both are not pointing to the same object, but double equal operator meant for what? Reference comparison. If both the references point into the same object, then only double equal operator returns true. But here I1 and I2 point into different objects. That's why what the answer we are going to get? False is the answer. Next, I1 dot equals of I2. I1 dot equals of I2. Do you know I1 and I2 whether point into the same object or not? So content wise both are same or not? Because dot equals method meant for what? Content comparison. So here 10, here 10 is there. That's why what is the output we will get now? True itself is the answer. I hope If you aware this point, then identity hash map concept is the very easy, because there this concept only play very important role. Are you able to understand? Just add one note, or otherwise keep subverting. Difference between double equal operator, difference between double equal operator and dot equals method, difference between double equal operator and dot equals method, difference between double equal operator and dot equals method. Okay, at the point, in general double equal operator meant for reference comparison within bracket address comparison, within bracket address comparison, reference comparison or address comparison, bracket close. Whereas dot equals method meant for dot equals method meant for what? Dot equals method meant for content comparison. Okay, example, take this example. I will use the same example in identity hash map also. So this knowledge compulsory you should have. Integer I1 is equal to new integer of 10, integer I2 is equal to new integer of 10, SOP of I1 double equal to I2. So the answer we are going to get what? False. I1 dot equals of I2. I1 dot equals of I2. Dot equals of I2. Answer is true. Better to take these diagrams also. I1 point into this object, I2 point into another object. Completed, right? Not required to keep any explanation, right? Now, so keep subverting identity hash map. Okay. So single word, it's a class name. Don't give space in the middle. Identity hash map. Single word. Identity hash map. Now listen. Identity hash map exactly same as hash map, except a small difference. What is the difference? Same, more or less same as linked hash map with a small difference. What is that? Here is, just observe this one. Sir, I am taking hash map. Legend this a bit carefully. Hash map m is equal to new hash map. It is a normal hash map object. Correct or not? Normal hash map object, hash map m. Now integer I1 is equal to new integer of 10. Integer I1 is equal to new integer of 10. Integer I2 is equal to new integer of 10. Integer I1 is equal to new integer of 10. Integer I2 is equal to new integer of 10 like. Now m dot put of, sir, here have you observed I1 point into 10, I2 is also point into 10 only. M dot put of, I want to add one key value pair. I1 is the key. Correct or not? I1 itself is the key. Next, what is the value is pavan, like I am taking. M dot put of I1 comma pavan. Next, m dot put of I2, m dot put of I2 comma Kalyan, like I am taking. M dot put of I2 comma Kalyan. system.out.println of m, SOP of m, like this. Sir, can you tell how many entries will be there in the map? How many entries will be there in the map? One entry or two entries? One entry or two entries? Okay, make sure. Can I use the term I1 and I2 are duplicate keys? I1 and I2 are duplicate keys? Yes sir. No, no. Ayo, yes or no? I1 and I2 are duplicate keys or not? No. How the JVM can decide these are duplicate keys? Who told you hash code is going to be considered? Okay, hash code is going to be considered to place location, to identify the location. So, in the case of hash map, normal hash map only, in the case of hash map, JVM will use dot equals method to identify duplicate keys. Are you getting? JVM will use which method? Dot equals method to identify duplicate keys. Was this key is already there or not? Okay. I1, suppose here I2 dot equals of I1 or I1 dot equals of I2 returns true or false? True or false? True. That's why duplicate keys are not. Yes. So duplicate keys. First 10 is equal to Pawan added. 10 is equal to Pawan added. Now I2 comma Kalyan I want to add. I2 dot equals of I1. True. Duplicate key. If the key is the duplicate, what will happen? Value will be replaced with the new value. So this value will be replaced with the Kalyan. Now SOP of M, the answer is curly brace open, 10 is equal to Kalyan, right? Then how many entries are there in the map? Only one entry, not two entries, make sure. Okay, you should aware. So 10 is equal to Kalyan only. So in the case of hash map, JVM will use which method to identify duplicate case? Dot equals method to identify duplicate case. So I1 dot equals of I2. I1 dot equals of I2 is true or false? Is nothing but true. So that's why and I1 and I2 are duplicate keys. Is it clear, right? Okay, this is that's why the output by default we are going to get 10 is equal to Kalyan, right? Okay, let me execute up to this. So and then we will continue about identity hash map. Normal hash map cinema. Let me show first. Here see hash map. M is equal to new hash map. Integer I1 is equal to integer of 10. Integer I2 is equal to integer of 10. M dot put of I1 comma Pawan, I2 comma Kalyan, SOP of H, SOP of M. Are you getting? Now what is the output, right? Java C. Here see Java C. Identity hash map demo dot Java identity hash map demo. What the output? 10 is equal to Kalyan. Correct or not? Okay, this. But now I have to convey. JVM, don't use a dot equals method to identify duplicate case. Can you please use a double equal operator to identify duplicate case? Don't use a dot equals method to identify duplicate case. Can you please use a double equal operator to identify duplicate case? If you want this one, then we should go for identity hash map. Are you getting that? What is the main difference between normal hash map, identity hash map? In normal hash map, JVM will use a dot equals method to identify duplicate case. But in the case of identity hash map, JVM will use a double equal operator to identify duplicate case. Are you getting? Now, suppose if it is the identity hash map, and observe, if it is the identity hash map, I1 and I2 are duplicate keys or not? No, because I1 double equal to I2, true or false? False. I1 double equal to I2 is false. Was I1 and I2 are not duplicate? If I1 and I2 are not duplicate, then how many entries will be there? 2 entries. 10 is equal to Pawan is there, 10 is equal to Kalyan is also there. Now let me cross check. Here see this one. Now let me replace. If it is a normal hash map, what is the output I got? Normal hash map. What is the output I got? 10 is equal to Kalyan. Because I1 dot equals of I2 I1 dot equals of I2 returns true because both are duplicate. Correct or not? Okay, this is. Now I want to take here hash map let me replace with the identity hash map. M is equal to new identity hash map. Identity hash map. Now see this one. Okay, what the answer by default? 10 is equal to Pawan, 10 is equal to Kalyan is there. Are you able to understand? Except this, there is no other difference between hash map and identity hash map. Everything is the same except this difference. Can you tell what is the difference? In normal hash map, JVM will use not equals method to identify duplicate case, which is meant for content comparison. But in identity hash map, JVM will use a double equal operator to identify duplicate case, which is meant for reference comparison. Right? Okay. At this point, keep submitting identity hash map. Identity hash map at the point. Identity hash map add. It is exactly same as hash map. It is exactly same as hash map. It is exactly same as hash map. Exactly same as hash map. Hash map within bracket, including methods and constructors. Including methods and constructors. It is exactly same as hash map, including methods and constructors, except the following difference. 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 Okay. Add next para. In the case of normal hash map, in the case of normal hash map, in the case of normal hash map, normal hash map, JVM will use. In the case of normal hash map, JVM will use dot equals method. Normal hash map, JVM will use dot equals method. JVM will use dot equals method to identify. JVM will use dot equals method to identify duplicate keys. JVM will use dot equals method to identify duplicate keys. To identify duplicate keys, comma, which is meant for content comparison. Which is meant for content comparison. Which is meant for content comparison. Content comparison. Next para. But next para. But in the case of identity hash map, JVM will use double equal operator. JVM will use double equal operator. JVM will use double equal operator to identify. JVM will use a double equal operator to identify duplicate keys. To identify duplicate keys. JVM will use a double equal operator to identify duplicate keys, which is meant for what? Which is meant for reference comparison. Which is meant for reference comparison. And for reference comparison within bracket, which is meant for reference comparison within bracket, address comparison. Address comparison. Okay. So take example. Take this one. This example directly. Hash map M is equal to new hash map. Hash map M is equal to new hash map. Next, integer I1 is equal to I1 is equal to new integer of 10. Integer I1 is equal to new integer of 10. Integer I2 is equal to new integer of 10. Integer I1 is equal to new integer of 10. Integer I2 is equal to new integer of 10. Next, m dot put of I1 comma Pawan. M dot put of I1 comma Pawan. M dot put of I2 comma Kalyan. M dot put of I2 comma Kalyan. Okay, like so SOP of M. What the answer na? 10 is equal to Kalyan. 10 is equal to Kalyan. Next term. Just better to take the diagrams also. And better to take diagrams also. Just beside this code, just add one theoretical point. I1 and I2 are duplicate keys. I1 and I2 are duplicate keys. I1 and I2 are duplicate keys because I1 dot equals of I2. I1 dot equals of I2 returns. I1 dot equals of I2 returns what? Returns true. I1 dot equals of I2 returns true. Like completed, I hope, up to this. Next para. If we replace hash map, if we replace hash map with the identity hash map, if we replace hash map with the identity hash map, if we replace hash map with the identity hash map, then if we replace hash map with identity hash map, then replace hash map with identity hash map, then I1 and I2 are not duplicate keys. I1 and I2 are not duplicate keys. I1 and I2 are not duplicate keys. Not duplicate keys because I1 double equal to I2. Because I1 double equal to I2 returns. Now what? I1 double equal to I2 returns false. I1 double equal to I2 returns false. Next, in this case output is can you spell out what the output we got? 10 is equal to Pawan, comma 10 is equal to Kalyan. Sir, both entries are there. 10 is equal to Pawan, comma 10 is equal to Kalyan. Like. So, have you observed, right? What is the difference between a hash map and identity hash map? More or less, both are exactly same. Now, the next terminology, okay, keeps abiding weak hash map. Weak hash map. Weak hash map. Sir, can you tell what is a weak hash map? The hash map which is very weak is called weak hash map. Normal hash map is very strong, but weak hash map is very weak. That's why the word weak hash map, right? Correct or not? No, ante. If it is no, if the answer is no, why the word weak? So compulsory relevant names only the some people are going to keep. So weak hash map, the hash map which is very weak is called weak hash map. Normal hash map is the strong, weak hash map is the weak. That's why the word weak hash map, right? Correct, believe me. Okay. After a few minutes, anyway, now you people may laugh, but after a few minutes, definitely you people are going to accept this word. Okay, but anyway, before going to this example or this terminology, I hope you people may aware garbage collection concept, GC. So majority of the people I hope attended GC concept, right? Just let me repeat for few minutes because there is one concept I have to use. Suppose I have an object is there. Sir, this is the object I have. Can you tell, is it eligible for garbage collection or not? Yes, eligible because this object doesn't have any reference. That's why this object eligible for GC, right? Now, so garbage collector came. Assume garbage collector came. Garbage collector came. Now, whenever garbage collector saw this object, have you observed next terminology you aware? Whenever garbage collector saw this object, garbage collector felt very happy because garbage collector got food to eat. What is the food to the garbage collector is useless objects only, right? Now, by seeing this object, garbage collector felt very happy. So saying, this object happily I can able to eat, like. Now the garbage collector came. It is dancing in front of this object. I'm going to destroy you. I'm going to kill you. Like this object, the garbage collector dancing in front of this object. Can you tell then what is the feeling of this object? Object starts shivering. Object starts crying like. Object starts shivering, crying like. Then garbage collector saw that. So garbage collector is not that much cruel person, having a bit mercy also. By seeing that, garbage collector approached this object. Object, definitely I'm going to kill you, because if I'm not going to destroy, then I'm not doing my job well. My job is to destroy useless objects only. Definitely I'm going to destroy, no doubt in that. But I will give one small chance for you. Do you have any last wish? Let me know. Chivara korika. Do you have any last wish? Let me know, so that I can fulfill. After that I will destroy you. Is nothing but like garbage collector conveyed to the object. Then what the object did is, boss, so garbage collector gave a bumper offer for the object. Then what the object is going to tell, boss, one database connection associated with me, one network connection associated with me. Can you please close all? Can you please close all? And then you can destroy me, no problem at all. Like garbage collector is going to convey to this object. Are you getting? Once a garbage collector, I mean object is going to convey to the garbage collector, boss, one database connection associated, one network connection associated. Can you please close? And then you can destroy me, no problem at all. Like object convey to the GC. To fulfill this last wish, garbage collector is going to call finalize method. Finalize method to perform which activities? Cleanup activities, right? Okay. Once finalize method completes, immediately garbage collector is going to destroy this object. Are you getting? Once a finalize method completes, immediately garbage collector can destroy this object. So can you tell who calls finalize method? Who calls finalize method? Garbage collector calls. When garbage collector calls finalize method? When the garbage collector calls finalize method? Just before destroying an object. For which purpose garbage collector calls finalize method? To perform cleanup activities, right? Any explanation is required? Just before destroying an object, garbage collector calls finalize method to perform cleanup activities, right? This knowledge you should have, because we cache map everything with respect to garbage collector only. That's why you should aware, right? Okay. Now listen. So have you kept a heading, right? Yeah, na? What heading you took? We cache map. Legend this one. So it is exactly same as Hashmap with a small difference. What is the difference? Very important difference, right? Legend. Sir, I am taking one normal Hashmap. Legend very carefully. Here I am taking one normal Hashmap. I will take. But before that, here let me take one simple class. I am taking class temp. Temp class I am taking. Class temp class. Here, whenever we are trying to print a temp object, internally which method will be called? ToString method. Have you remembered? Let me override ToString method. Public string ToString method. Okay. Return what? Temp. Like this I took. Class temp, public string or ToString method, return temp. Like this I took. Now here, and whenever temp object eligible for GC, JVM is going to call, garbage collector is going to call finalize method. Let me keep finalize method also, so that whether temp object got destroyed or not, we can able to get confirmation. That's why what I am doing here is public void which method? Finalize system.out.println finalize method called. Like I am taking end of the, okay, this is a temp class, right? Are you able to understand? Okay, this is a finalize method called like I am taking. So this is the temp class contain how many methods? Two methods. Okay, ToString method is there, finalize is there. If temp object destroyed by GC, then automatically finalize method will be called. That is the guarantee. So that if a finalize method called, SOP is there. If this line I can able to see is nothing but temp object destroyed by garbage collector, right? Now leave that part. Now here see this example well. Sir, I'm taking one hash map. I'm taking one hash map object. Here, see, observe carefully. Hash map. 1 minute. Next, the space adjustment. Here, hash map. M is equal to new hash map. I created one hash map object. Okay, like so hash map object got created. This is the hash map object, right? Okay, like hash map. We created map object M. Now let me create one temp object. Temp T is equal to new temp. Sir, I created an object of this class, temp class. Now M dot put off. M dot put off. M dot put off. T means what? Key. Yeah. And the value is Durga. Some value, key value. Because key can be any type of object. Value can be is nothing but any type. Of course, in this case, temp object is the key, Durga is the value. Now let me print system.out.println of M. Do you know how many entries are there in the map? How many entries are there in the map? One entry. What is that entry, Anna? Temp is equal to Durga, like we have. Temp is equal to Durga like this we have. Now take a bit special care. Total, so here observe, map object, temp is equal to new temp. Sir, I created one temp object. M dot put of T comma Durga. Oh, now this one acts as a key. And the Durga is a content, right? So key value, Durga is the value. SOP of M is nothing but temp is equal to Durga. Now what I am doing is T is equal to null. Sir, T is equal to null. If T is equal to null, this one doesn't have any reference. Are you getting? T is equal to null means this one doesn't have any reference. Now I call system.gc. Observe a bit carefully. I called system.gc. Then immediately garbage collector came. Assume garbage collector came. Whenever garbage collector came and saw this object doesn't have any external reference. Only this reference is there, but doesn't have any other reference. That's why garbage collector came and dancing in front of this object. Hey, I'm going to kill you. I'm going to destroy you, like a garbage collector dancing in front of this object. Then what this object is going to do? It starts crying. Oh, someone came to kill you. Then this person starts crying. Whenever this key starts crying, hash map heard that. Oh, some key is crying. Like immediately hash map went there nearer to this object. Observe carefully. Whenever hash map went there nearer to this object, and hash map asked, why key or why object, why you are crying? Then immediately this object is telling, garbage collector came. It is telling that it is going to destroy me. So it is dancing in front of me. That's why it starts crying like. Then hash map asked, why object, where is the garbage collector? Then this object showed, here is the garbage collector, like. Then immediately hash map went there and gave left and right. Okay, they say went there. Hash map gave left and right. Why you are here? Why you are in this location? Like. Then immediately garbage collector telling, this object doesn't have any reference. That's why I came to destroy. Hey, garbage collector, have you saw this object associated with me? How you can destroy? Associated with me, how you can destroy? Like hash map, so convey to the garbage collector. Even except this link, no other reference, right? That's why I want to destroy you, like. And hash map gave left and right. With the crying, garbage collector went and approached one person. Who is that person? JVM, right? Now JVM asked, Hare garbage collector, why you are crying? hash map gave left and right. Okay, then JVM is going to convey to the garbage collector saying hash map is stronger than you, don't go that side once again. Okay, they say don't go that side once again, like JVM is going to convey. Are you getting? Even though object doesn't have any reference, so if it is associated with hash map, that object not eligible for garbage collection. Are you getting that? So is it eligible for garbage collection or not? No. Even though garbage collector came, I call system.gc, garbage collector came, but still garbage collector can't destroy this object. If garbage collector destroy this object, then I can able to say finalize method called like, okay, this is, but so my main thread waiting for some time, thread dot sleep 5 seconds a time. Assume that 5 seconds time main thread is waiting. Garbage collector really is going to destroy this object or not? Garbage collector can't destroy this object. If you want, you can print SOP of M once again, but the output by default you are going to get second time also temp is equal to Durga only. Are you able to get? So in this case, hash map and garbage collector, who dominates? Hash map dominates garbage collector, right? Even though object doesn't have any other reference, still this object not eligible for GC if it is associated with the hash map, right? Now the terminology is very clear. Let me execute up to this so that you can aware first. Here see. Here I am taking weak hash map. Yeah, of course, name of the program weak hash map, but I am taking normal hash map only. Here legend, hash map M is equal to new hash map, temp T is equal to new temp, hash map M is equal to new hash map, temp T is equal to new temp, M dot put of T comma Durga, next SOP of M was first time, what the answer? Temp is equal to Durga, T is equal to null, oh that object eligible for GC, system.gc garbage collector came, but garbage collector is it going to destroy temp object or not? No, my main thread is sleeping for some time. Main thread is sleeping for some time. After that SOP of M, or the answer we are going to get temp is equal to Durga only. Is it clear? Because garbage collector can't destroy this object because it is associated with the hash map right now. Let me run this code. Okay, here see Java C weak hash map demo.java. Next Java weak hash map demo. Weak hash map demo. Okay, like first time temp is equal to Durga, second time also temp is equal to Durga. You are getting? If the garbage collector came, but a garbage collector destroyed that object? No. If a garbage collector destroyed a temp object, clear indication finalize method will be called. Then SOP statement is there in the console, I can able to see finalize method. Are you getting? So hash map and the garbage collector, who dominates? Hash map dominates garbage collector, right? Now up to this is the clear. Now the same cinema, let me run with the weak hash map. Here legend this one. Sir, I replace with the hash map with the weak hash map. Here also weak hash map like I added. Now once again starts from the beginning. Weak hash map M is equal to new hash map, weak hash map. Now I created weak hash map, right? Okay. Temp T is equal to new temp. Sir, I created one temp object. T is the reference variable. M dot put of T comma Durga. SOP of M. What the answer we are going to get? Temp is equal to Durga. Because at the beginning both key value pair is there. That's why temp is equal to Durga. Now T is equal to null. Boss, this one gone. T is equal to null, gone. System.gc. Garbage collector came. Listen carefully. Garbage collector came. Now my main thread is in sleeping. Now the garbage collector starts doing. Garbage collector came. And the garbage collector is dancing in front of this object saying, I am going to destroy you or kill you. Then object starts crying. Weak hash map heard that. Hey, some key is crying. Like immediately this weak hash map, so approached this object. Object, why you are crying? Then immediately this person told, okay, why you are crying? Then immediately this person told, garbage collector came and it's going to tell it starts destroying. It will destroy me, like it is telling like, where is the garbage collector? Like, so weak hash map asked the object. Then object showed that garbage is here. Then immediately weak hash map went there went there nearer to the garbage collector. So then Vcache map asked, hey garbage collector, why you are in this location? Garbage collector, why you are in this location? Like, okay, this Vcache map asked the garbage collector. Then the response from the garbage collector is simple. Hey Vcache map, you are already weak. Okay, this is, you are already weak. Don't open your mouth. Let me complete my job. Is nothing but like garbage collector is going to convey to the Vcache map. Then Vcache map realized, oh, I am weak, right? Now this person came back and stand. Now this garbage collector is going to destroy this object. Call finalize method, destroy this object, and then automatically this value also gone. Because if key is not there, value also by default will be gone. Now my main thread after 5 seconds starts printing SOP of M. This time, can you tell what the answer now? Just a curly brace open, curly brace close. Temp is equal to Durga gone because garbage collector destroyed this object. Are you getting? Even though object associated with Vcache map, if this object doesn't have any other references, garbage collector destroy that object. Okay, this is garbage collector Vcache map. Who dominates? Garbage collector Vcache map. Who dominates? Garbage collector dominate Vcache map. Normal hash map, garbage collector. Who dominates? Hash map dominates. Can I use the term? The hash map which is very weak is called Vcache map. Correct or not? Ayo, same. This is the example. Let me run this code first. Vcache map also. Here see, if it is a normal hash map, so both the times, do you know, normal hash map, what is the output we got? Normal hash map. Temp is equal to Durga, temp is equal to Durga. Finalize method won't be called because garbage collector can't destroy that object. Now, I am taking instead of hash map, Vcache map. M is equal to new Vcache map. Vcache map M is equal to new Vcache map like. Yes, the code compiles fine. But the answer is, have you observed? Temp is equal to Durga. Finalize method already called. That object story already completed. Now curly brace open and close. Are you getting? Where is the temp is equal to Durga? Not there. Because the reason you aware. Is it clear for all of you, right? Not required to keep any explanation. So this is what is Vcache map. Normal hash map, Vcache map. I hope the terminology is clear at this point. Vcache map. Yeah. It is exactly same as hash map. It is exactly same as hash map. It is exactly same as a hash map, except it is exactly same as hash map except the following difference. Except the following difference. Except the following difference. Except the following difference. Next para add. In the case of hash map, even though object doesn't have any reference, it is not eligible for GC. If it is associated with hash map. That is hash map dominates. Hash map dominates garbage collector. Hash map dominates garbage collector. Next para. But in the case of Vcache map, comma, if object doesn't contain, any references, it is eligible for GC. If the object doesn't contain any references, it is eligible for GC. It is eligible for GC. It is eligible for GC. Even though object associated with weak hash map. Even though object associated with weak hash map. Object associated with weak hash map. That is object associated with weak hash map. That is garbage collector dominates. Garbage collector dominates weak hash map. Garbage collector dominates weak hash map. Okay, that's all. Now take this example, right? Now take this example. Yes, I hope completed, right? At the theory. In the above example, temp object not eligible for GC. In the above example, temp object not eligible for GC because it is associated with hash map. Next, in this case output is can I spell out what the output ana? Temp is equal to Durga. Second time also what the answer? Temp is equal to Durga, like temp is equal to Durga, both the times temp is equal to Durga, like Clear, right? Okay, next para. Next para. In the above program, in the above program, in the above program, if we replace, in the above program, if we replace hash map with the weak hash map, in the above program, if we replace hash map with the weak hash map, if we replace hash map with the weak hash map, hash map with the weak hash map, then if we replace hash map with the weak hash map, then if we replace hash map with weak hash map, then here just observe, then temp object eligible for GC or not? Yes, then add, then temp object eligible for GC, temp object eligible for GC, temp object eligible for GC, temp object eligible for GC. In this case output is, in this case output is, can I spell out what the output we are going to get in this case? Better to take from screen. Temp is equal to Durga, temp is equal to Durga, finalize a method called, temp is equal to Durga, finalize method called curly brace open and close, temp is equal to Durga, finalize method called curly brace open and close, like this. Completed, right? Okay, that's all. This is about weak hash map, normal hash map, weak hash map. Observe the difference, right? Are you able to understand? A small difference is nothing but like identity hash map, normal hash map, linked hash map, normal hash map, all are with a small differences, right? Okay, that's all.